Here I want to do a few examples of taking a compact logarithmic statement and expanding it into sums and differences of logs. We're going to do that by using kind of these three major rules of logarithms. And I kind of like to number them. I just kind of like to say rule 1 is going to be that the log of m times n is the same thing as the log of m. Oops, teacher with a tablet trick. Ran out of space, but I get to slide over. Plus the log with the same base times n. Then similarly, well, this one's a little different. So I do log base a of m raised to the p is the same thing as p times log base a of m. And then our third rule here is going to be that the log base a of m divided by n is the same thing as log base a of m minus, oops, picture with a tablet. Handwriting's getting bigger, or I have more to write. Log base a of m. All right, now it's bothering me that those aren't starting at the same point. There we go. All right. So those are the three main formulas that we're going to use during these kinds of transformations. And so what I want to do is I want to take this log base a of this complicated thing, and I want to write it as a sum of a bunch of different log base a's. Well, I can use that first law here, that first formula, and I can say, well, this is 6 times x, this is x times y, this is y times z, right? Those exponents are still there, I'm just not saying them. Okay, well, that means that this is going to be log base a of 6 plus log base a of x plus log base a of y to the 5th plus log base a of z to the 4th. I'm also going to use 2 here, and I'm going to bring those exponents down to coefficients because this is going to be the simplest version of these logs. And so I have log base a of 6 plus log base a of x plus 5 times log base a of y plus 4 times log base a of z. And what this is really saying is now I just have 4 copies of log base a of z added together, and 5 copies of log base a of y added together. And so that's why I'm saying let's go ahead and pull those coefficients out so we can see these as just sums of logs of values rather than values raised to exponents. Okay. Well, it wasn't a ton of fun, but it wasn't too awful. Let's take a look at another one. Let's look at, what about log base b of p squared q to the 5th over m to the 4th and then b to the 9th. And let's do the same thing. Let's try to break this up into the sums and differences of logarithms, the same way that we broke this last one up into sums and differences of logarithms. Well, the first thing I'm going to see is that I've got, a numerator over a denominator. And I'm going to use kind of that third rule here. And I'm going to say a numerator over a denominator is going to be 1 minus the other. Okay? And so this is going to be log base b of p squared q to the 5th minus log base b of m to the 4th b to the 9th. Okay, now I'm going to want to use one on that one, and 1 on that one to break those two apart. Not forgetting that that negative applies to this entire logarithm. And so as I break that apart, that negative needs to apply to all the sub-pieces that come from that log b of m to the 4th b to the 9th. Okay, and so I have log base b of p squared plus log base b of q to the 5th minus, parentheses, log base b of m to the 4th plus log base b log base b of b to the 9th. Okay. Now, on each one of these, I want to use that third rule, right? This one's going to be a little bit funny. We can use the third rule, or we can analyze it on our own a little bit. And that third rule is, oh, I'm sorry, that's the second rule. Yeah, and that actually I was using, I just need to, I labeled the rest of them correctly, but this is the second rule that I want to use, the way I labeled them earlier in this, because I'm using this idea that I can take the exponent and I can turn that exponent into a coefficient. And so what I wanted to do here is I wanted to take that p squared and put that 2 out into the coefficient. I want to take that q to the 5th and turn that q to the 5th into a coefficient. And so what am I going to have? I'm going to have 2 log b of p plus 5 log b of q. And we'll go ahead and distribute that negative through and have minus 4 log b of m. And then 2 ways to think about this. This is an exponential function. This is a logarithmic function. They are inverses of each other. That means that one undoes the other and leaves me with the input, right? The input to the composition of these functions. And so what I really have is I have an f of f inverse of x. And so I have 2 functions that undo each other and just leave me with this 9 behind. And so I know my answer is literally just going to be -9. I mean, I know that right now. But I can get to that from there through that analysis. Or I can get to that a little bit longer. And I'll go ahead and write the little bit longer out here. Oops, let's carry that 5 along. I can also get to that by kind of following through with these rules and saying that this is minus 9 log base b of b, and then saying that this is b to the 1, right? And so my log base b is my f inverse, my b of x, my b of 1 is my f of x, and so log base b undoes b and then leaves me with a 1 behind, and that's really just 1. This whole thing is 1 times 9. And so this whole thing equals 1 times -9, which is -9. And so my answer here is going to be 2 log base b of p plus 5 log base b of q minus 4 log base b of m minus 9. It's a little bit tricky because that last log term goes away and just becomes a constant because I have a log base b of b. Hope that helps out.